Hello friends, today we are going to solve PSA problem of HackerEarth. It is a current running challenge on a HackerEarth Collins Codebank who is hiring for Python and Java full stack developer. So it is a tree based question. So firstly I can go through the question. You are given an undirected tree with n nodes. You are also given an array A of n integers which denotes that node of I is assigned a value equal to A of I. So we have a tree having n nodes and we have an array which tell us about the value of particular node of I. So array of I having a value of node of I. So what our task is, to determine the sum of medians of odd length simple path starting from node 1. So let us, we have a tree whose root node is 1. Then what our task is, to find the median of all the odd length simple path starting from node 1, its median values sum. So let us take we have one based indexing. We take an example. If n equals 4 and a equal 4, 21, 1, 5, node 1 has a value 1, node 2 has a value 21, and so on, and edges is 1 to 2, 2 to 3, 2 to 4. So we have this tree, it has 1 to 2 edge, 2 to 3 edge, and 2 to 4 edge. Then there exist three odd length simple path. One is node 1 only, then second is 1 2 3, then third is 1 to 4, and the median value of node 1 is 4 because it has only one node whose value is 4, and the simple path to 1 to 3 has three nodes. One has a value 4, 2 has a value 21, 3 has a value 1. If we arrange this value in a sorted order, then it becomes 1, 4 and 21. And value and simple path 3 has a value 1, has a node 1 to 4 has a value 4, 21 and 5. If we arrange this in a sorted order, then it become 4, 5 and 21. So if we found the median, so node 1 has a median 4, simple path 1, simple path 2 has a median 4, and simple path 3 has a median 5. So 4 plus 4 plus 5 is become 13. Now we can understand how to approach this problem. This is a tree problem, and in this question predominantly we see we have to traverse the tree and find sum of all the medians. So if we think about the brute force approach, so brute force approach should be like at one traversal we can find one simple path having odd length, and then we find the median, and then we can like store it in our global sum. So this is our brute force approach. So running time complexity of this approach is, first we have to do n traversal at max, so n into each traversal require n time complexity into n. Then we have to find the median. So how we can find the median? So we have a when we traverse any simple path, then in a list we store its all nodes value in that path in one list, and then we have to sort that list. So sorting requires n log n time in worst case. If we are using merge sort, then n log n for one simple path. What we have to do, first traverse, then sort the simple path nodes value. So at max it has n nodes, so n log n. So total time complexity is n into n log n, because the traversal and sorting, it is not a single process, it is two different process. One is, it is represent total traversal, and in another we have n for single path traversal, and here also n log n for sorting. So we have to choose maximum, so n log n, and from first we have n, so it becomes n square, n into n log n square, n log n. We have brute force time complexity. Can we improve it? Yes, we can improve it. We can improve, how we can improve it? From n square log n to how much we can better achieve it. So we are doing traversal, then we are doing traversal for every simple path. So can we do only traversal one time and then we find the median? Yes, we can. How we can? We can either do DFS or BFS, and when we are doing traversal, at that time only we can check the length of the path, and we can also pass previous information, which is a list of values of that particular path. So we can do in that way. In that way we only have to do one traversal. So only one traversal. If we are doing, let us take an example of this graph. If we are doing for this graph, if we are passing n1 4, so what we are, if we are from n1 we are coming to n2, so what information we should have? We should have what is our previous node n1 and what all values it has in the simple path. So it has only one value 4. If we are coming n2, then what we have, what information we should have? We should have where we are currently at 2 and what all values this path have, 4 and 21. Then if we are coming n3, then what current value this node has, 3, and what all values it has, 1, 4 and 21. So in a sorted order. How we can achieve this sorted order thing? We can achieve this sorted order thing when we are coming from n2 to n3 and we have to insert v equal 1, value equal 1. Then we insert this value in a sorted form. In a sorted form, how we can achieve this sorted form? We are inserting this value in a insertion insert method. We are using insert of insertion sort method to insert the value. So it only takes O of n time. So total time complexity of second method become semi-optimized method, become method time complexity O of n square. And here I am going to code this method, and also at the end of this tutorial I will tell you the optimized approach, so you can apply that approach by yourself. Now we are coming to our code editor to code for semi-optimized solution. So first we are creating the find the median sum. First we are creating the find the median sum function, which will take two parameters, a and edges. A will have values for nodes and edges will represent the edge of given graph. Now we are creating one graph class which will help us to implement the graph creation logic. So we initialize the graph class with graph. Our graph is a default dict self. Now we are creating another function add, which will help us to add the edges in the graph. As it is bidirectional graph, we can add both the edges from U to V and from V to U. Now we are creating the find median sum function for this graph, and we implemented the code logic here. So for firstly, if we are doing BFS, then we have to create one visited array which is of size n plus 1, because our index starts from 1. So visited of 0 equal true, and then we have to store the median sum. So we are creating one variable, and now we have to require one store which stores the current index and the list associated with it. So our initial index is 1 and list associated with it is a of 0. While our store has some value, what we can do, we can pop that value and our node become value of 0 and array become value of 1. And we can find the length of this array if this array is of odd length. it means we require its median to be added in our main median sum. So our array, and we know that our array is sorted array, so the middle element is its median. So n by 2 we are doing here, and as we process the array we need to change its visitor state to true. Now we find the neighbors of this node, and we are checking if visited of neighbor equal false. Then what we can do, we can append this neighbor in store. So before that we have to update the array, so its neighbor value is being inserted in the array at the correct position, so our array remains sorted. So for that we are importing module copy. From copy we are importing deep copy, and here we are creating one def self. This function takes two parameter num and array, so it will place this number at correct position in the given array. So first we are finding the length of array, then we are appending this num at the last position. Now we are checking if n is greater than 0, then what we are doing, if array of n is smaller than array of last element n minus 1, then we are swapping these two elements. This is same as insertion sort logic. Insert in insertion sort, and we are reducing its value by 1, else we break and then we return this array. And here we are storing neighbor comma inserted at the sorted position self dot this, and here we are sending a of neighbor minus 1 comma array. This is our new array, new value in a store. New value, we are storing this here. Now after all this we are returning the value of median, and we are updating the median sum here, so it is median sum, while this is in store. So we have to create a graph here with the length of a, and now we have to populate this graph. Find median sum a. So, and we are printing our answer here. Now we have to impute our test. So there is slight mistake here. It comes dot. It should not be here dot. Now add missing one required positional argument. We are missing some argument here. Which argument we are missing here? We are missing here. We are passing edge. So we actually pass edge 0 here and edge 1 here. Now it will give us error list index out of range, array equal value of 1, array equal value of 1, line 31. Line 31 is array equal value of 1, and it is showing array equal value of 0. So we are storing this. Then if we are, so this is being our single thing store store. Now we have to append this whole thing inside the store. So we are getting 4 here, which is not a right answer. Why it is so? Because we are in some we are finding array median sum. Let us debug. Let us try to debug this. We are printing here store. Now we are seeing what happens to it. So 1 comma 4 4 comma 21 3 comma something. So we need to pass here deep copy, actually copy of this array. Yeah. So as in Python, in a function, we are if we are passing any list or tuple, it is passed by reference. So when we are passing here array, then what happens? It will populate this array with this new number. But we do not need to populate the our original array. We need to create a copy, and then we have to put this element. So now we are getting the correct answer. Now let's check for another input, and here we are getting the 7. So let's do a finger cross and let's check. Let's try to check whether we are getting the correct solution or not. We are getting the right answer. So friends, this is our semi-optimized solution for our tree value problem. So how we can optimize this problem, how we can optimize this solution. So what all our observation is. So for the BFS or DFS, we only takes O of n time, and another O of n time we are actually rearranging our element in a insertion sort way. So friends, so friends, what is our observation? Our observation is for doing BFS, we require only O of n time, but another O of n time we are spending in doing insertion sort insert logic. So can we improve that, or can there is any other way to finding the median without using the insertion sort insert method? Yes, we can do. We did the same thing in one similar problem, find the running median in the array. So if we apply that concept here, then we can easily solve this question in less time complexity. So this basically this tree value problem is a mixture of two problems. One is simple BFS and another is find the running median. Thank you friends.